If a die is tossed twice, what is the probability of getting a sum of at least 10? Now we are dealing with probability. If I toss a die, the probability of having a 1 is 1 over 6. The probability of having a 2 is still 1 over 6. The probability of having a 6 is still 1 over 6. Isn't it so? Because it is just one phase, irrespective of the number written there, that is shown out of 6 other phases that could have come out. Is that okay? Now, let's go into the question. The question says the probability of getting at least a 10. That means I toss the die first time and I toss it again second time. And when I add my first toss and the second toss, I should have a sum of at least 10. At least 10 means 10 and above. That's 10, 11, 12. That's the highest you can have from tossing 2 dice. Is that okay? Now, what are the combinations that can give us at least a 10? I could toss 4 the first time, and the second time it could be 6. I could toss 6, and the second time it could be 4. Now, all these add up to 10, right? 10. Then let's get higher, because you can't go to 9 because the question says at least 10. So I could toss 5, and then I could toss 5 again the second time. Or I could toss, this time I could toss 5, and then the second time is 6. Then I could do 6, then 5. Or I could have a double 6. Now these are the combinations of how I can have at least a 10. Now what does this mean? This means this and this, right? I could have the probability of having a 4 and then having a 6. Probability of having a 6 and then a 4. How do you interpret and in probability? Probability of having a 4 and probability of having a 6. How do you interpret that in probability? It means probability of having a 4 is what? 1 out of 6 phases, right? And probability of having a 6 is what? Still 1 out of 6 phases. How do you interpret and in probability? In probability, and means multiply the two probabilities. Is that okay? So this one and probability of having a 4 is still going to be the same thing. 1 out of 6 multiplied by 1 out of 6. Assuming I do this for all of them like this. So what would I be looking at the end of the day? I am simply looking at what is the probability of having this or this or this or this or this or this. So what am I saying? I'm simply saying that the probability of having at least a 10 is the probability of having this and this, or 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 this and this. Remember, we've gotten an for this. So what's the answer to each of these? What's the answer to 1 over 6 times 1 over 6? The answer is 1 times 1, 1. 6 times 6, 36. So the answer to each of them is 1 over 36, 1 over 36 till the end. So we are going to have 1 over 36 or 1 over 36 or 1 over 36 till I get to the end. Like this. How do we interpret or in probability? To interpret or in probability means addition. So this is going to be plus, 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 plus. Okay? Let's write it out. So what's the LCM of all these guys? It's 36, isn't it? Now this is going to be simply 1, 1, 1, 1, 1, 1. I know we all know how to handle fractions. So I'm not teaching fractions here. So it's going to be 1 plus 1 plus 1 plus 1 plus 1 plus 1 is what? That's 6 over 36. And that is also what? 6 here, 1, 6 here, 6, 1 over 6. And what option is that? That is D. But again, if we don't want to go through this stress, there's a simpler way of solving it. Let's look at it. So I'm going to draw this table. 1, 2, 3, 4, 5, 6. These are the faces of the die. 1, 2, 3, 4, 5, and 6. So I'm going to have something like this. Now, what is going to happen here is that the first die, the first time I toss the die, I have 1. The second time, I can also have 1, right? I'm writing out all the possible combinations that can come out of tossing one die twice. So, first time, second time, or 1, 2, or 1, 3, or 1, 4, or 1, 5, or 1, 6. That is this one and these combinations. Or 2, 1, 2, 2, 2, 3. Now just keep doing that till we get to the end. Now these are all the possible combinations, and if you count, you're going to have 36 possible combinations, and that is what we had. The denominator in the previous method, it was over 36. Now what are the possible ways of having at least a 10? At least a 10 means anything 10 upward. So this is 12, right? A sum of 6 and 6 is 12. A sum of what? Look at this. This is 11. 11, right? This is 10. This is 10, and this is 10. This is 9, 9, 9, 9. So how many are there? 1, 2, 3, 4, 5, 6. 6 of them. Out of how many possible ways? 36. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 36 possible ways. And what's the answer? 6 here, 1, 6 here, 6. And that is 1 over 6. Still D, as we got before. So you see, whichever method you like, you can go for it.